Okay. Shh, focus. Okay, homework 8. What questions do you have? Well, we're going to do both, but 8 has endpoints, so let's practice that first. Number 2? Sure. Okay, let's start with 2. What would you choose as your u?
Negative 2x.
Okay, so u is going to be negative 2x, which means that du is negative 2 dx, which means that dx is du over negative 2. So far, so good? Okay, we're rewriting our integral. So this is e to the u, because my 2x is now a u. And then my du is a du over negative 2. I'm going to pull that to the front. This is what we learned yesterday, that when you rewrite your integral, negative a half e to the u, you are going, yes, Ahmed? The homework from yesterday? You are going to change your endpoints. How do I know what to change them to? Plug them into u. So my upper endpoint used to be a 1. Now that I plug it into a negative 2x, what is it now? Negative 2. Okay, so I take my 1 and my 0. I plug them in here. Negative 2 times 1 is a negative 2 on top. And then negative 2 times 0 is a 0 on bottom. Then what's the integral of e to the u? Negative 1/2 in the front, e to the u again. And then I plug in negative 2 and 0. This is what you missed yesterday, Angel. Okay, then I plug in my negative 2. So I have negative a half e to the minus 2, which is negative a half e squared on bottom. Are we good with that?
So we weren't supposed to put u back into it?
Correct, because remember, when you change your endpoints, then you don't go back to x's. Thank you. Okay? Bottom one, we're plugging in a 0. So I have negative a half e to the 0. But e to the 0 is 1, so it's negative a half. Now, for your final answer on this, I can't remember if I did one with y'all yesterday, but if it was minus a half e squared, and then minus a negative a half, that's going to switch to a plus, right? Okay, but then the other thing on the AP test that they love to do is to look for GCFs and factor them out. So if both of these have a half, they would pull the half out and write it as 1 minus 1 over e squared. Okay, now, those are obviously the same, right? Okay, it doesn't matter to me which one you do, but you should be aware that for multiple choice, they're going to look for those GCFs and pull them out, so you have to do a little bit more work to choose your correct answer. Okay? All right, bless you. Next one I heard was 15, right? So go ahead and flip over to the back side, number 15. Okay, 15 is here. What do you guess we're going to choose as our u? Okay, x squared minus 3, which means that our du is, well, the derivative of it. That's for an antiderivative. It'd be just 2x. Because remember, you're taking the derivative. So antiderivative is when you're integrating. Du means derivative. Okay, then dx is going to be du over 2x. So far, so good? Okay, so I have the integral 6x over. This down here is my u, so it's a square root u on bottom. And then my dx is now a du over 2x. What am I going to pull to the front if I have 6x divided by 2x? Just a 3. What happens to the x's? Good. Now, if it's 1 over square root u, what is that the same as? Negative a half. Very good. Okay, and then at this point, I change my endpoints so that I never have to go back to x. So my original endpoints were root 12 and 2. Let's do root 12 first. What is root 12 squared? Minus 3? 9 on top. Next, I'm plugging in 2. 2 squared minus 3. What do I get? 4 minus 3, which is 1. And now I work the integral and I never go back to x's. So add 1 to minus a half. I'm adding 2 halves. What is negative a half plus 2 halves? Okay, u to the positive a half. Then I divide by a half, which is the same as multiplying by 2. But I already had a 3 here, so it's a 2 times 3, which is 6. Then I'm going to plug in a 9 and a 1, and then subtract. When I plug in the 9, that's going to be 6 times the square root of 9, or 9 to the half. Square root of 9 is 3. 3 times 6 is 18 on top. Bottom one, plugging in a 1, you're going to have 6 times the square root of 1, which is 6. Then subtract those two. 18 minus 6 is 12. Make sense? Okay, what else? 17 or 12. Let's do 17 first, and then we'll come back to 12 if we need to. Okay, so number 17, what do you guess we should pick as our u? 2 theta. And if u is 2 theta, then what's du? The derivative of 2 theta, which is just like a 2x. Just a 2d theta. Then I divide by 2. D theta is du over 2. Good so far? Integral, I have secant squared u. And then du over 2. I'm just going to put the half in the front. Okay, I know my du is over 2. Well, then let me just put it there. And then my endpoints, how do I find them? I take the endpoints and plug them into u, which is 2 theta. So if I plug pi fourths, I have 2 times pi fourths. What's that? Pi halves on top. And then pi twelfths times 2 is 2 pi twelfths, which is pi sixths on the bottom. Then what is the antiderivative of secant squared? Tan. So it'll be a half tan u, plugging in pi halves, and then pi sixths, and then subtracting those results. Does that all make sense? Okay. Now, when I do pi halves of tan, remember that tan pi halves is going to be sine pi halves divided by cosine pi halves. So pi halves is your thumb, sine's your bottom fingers. Everybody's on bottom. What do you get? 1. Okay, then on the other part, cosine, I'm at pi halves. I want the top. How many are on top? 0. 1 divided by 0 is undefined. DNE. Very good. Now let's talk about y. Okay, pretend like you care. But secant squared has asymptotes anywhere that cosine is 0. When is cosine 0? At, okay, pi over 2, which is between pi fourths and pi twelfths. So think about, if I'm trying to integrate on an asymptote, can you tell me the exact amount of area if the asymptote goes up to infinity forever and ever and ever? No. This is not integratable. And it's not integratable because there is a vertical asymptote. I cannot find the exact amount of space under a graph that goes up forever and ever and ever and doesn't actually have a specific amount of area. Okay? All right. Anything else off of this homework that we want to work? Like 6 minutes left. 9 is pretty similar to 15. So, I'm sorry, I meant to say 13 is very similar to 15. So I'm not going to do 13. Let's see 9. Oh, we can do 9. Okay, so look at number 9. What's my u going to be? Take a guess.
X squared plus 2x.
Okay, very good. My u is the exponent, x squared plus 2x, which means that my du is dx. Which means that my dx is du over 2x plus 2. So far, so good? Okay, when I rewrite my integral, I have integral of x plus 1 kind of hanging out. This is now an e to the u. And then when I replace my dx, I have du over 2x plus 2. Now, I'm not going to write that because I need it to cancel out with an x plus 1. How can I change this? Take a 2 out. So this is the same as this. And why is that better? Because now I can cancel out the x's. What can I do with the 2? Pull it to the front as a half. So really, this is the integral of a half e to the u du. What do I do next? Change my endpoints. My original endpoints were 0 and 1. I'm plugging those in here. So I have 1 squared plus 2 times 1, and 0 squared plus 2 times 0. What is my top endpoint? 1 plus 2 is 3. What's my bottom endpoint? 0. What's the antiderivative of e to the u? Keep the 1/2 on the inside. Then we're plugging in a 3 and a 0. Plug in 3 first, you have a half e cubed. Plug in 0 second, you have a half e to the 0, which is the same as 1/2. What is e to the 0 really? Just a 1. And then if I were to subtract those, I'm going to do it both ways. Okay, a half e cubed minus a half is fine. Or, if I take the half out, what would be left? Good. Okay, and then remember, this is probably what they would put if it were multiple choice. Okay, I'm fine with this. That's not wrong. But it's not likely to be how they would present the answer choice if you had to pick one. Okay? All right, we have 3 minutes left. Anything else? One more? We can. I just have to, with this new recorder, I can only record in 15-minute increments. So, because I'm on the free version. So.
Number 7, you would be back to that.
What happened to your older port?
No, it just keeps recording with no sound. It's called Ladybug.
I would change it.
Number 19.
19? I know, I want to. But okay, 19 you're doing without u sub. Without u sub. So what that means is that I'm going to have to make that a power rule. How do I multiply x times x to the half? What do I do with their exponents if I'm doing x to the 1 times x to the half? What do you do with the exponents? Add. When you're multiplying bases, you're adding exponents. So for my rewrite, that's really x to the 3/2 minus x. Does that make sense? So x times x to the half is really x to the 3/2, then I'll do power rule. So antiderivative, we're adding 2/2. What's 3/2 plus 2/2? X to the 5/2. Divide by 5/2, what's in front? 2/5. What's the antiderivative of minus x? 1/2 x squared. Why do I not change the endpoints? I didn't do u sub, right? So I'm plugging in a 4, then a 0. Okay, plugging in a 4 first, I have 2/5, 4 to the 5th and square rooted, minus 1/2, 4 squared. Square root of 4 is what? 2. 2 to the 5th is 5 2's times together. So 2 times 2 is 4. Times 2 is then 32. So this is 32 minus 4 squared is 16. Half of that is 8. Oh, thank you. So that'd be 64/5 minus 8. Are we good with that?